Here are solutions to homework set number 8 for ECE 111. In this homework set, we're looking at problems that you'll encounter in EE 206 Circuits 1. How to solve those with MATLAB. The first problem looks at a resistor. The basic equations for electrical computer engineering is V equals IR, voltage is current times resistance, and power is volts times amps. So given any two terms, you can find the rest. For example, if I know I have 32 volts, 2.4 amps, then I know that volts divided by amps gives you resistance is 13.3 ohms. Volts times amps is power, 76 watts. If I know the amps and the watts, I know that watts divided by amps gives you volts. Volts divided by amps gives you ohms. Given ohms, or volts and ohms, volts over ohms gives you amps, volts times amps gives you watts. And given amps and ohms, ohms over amps gives you volts, volts times amps is watts. So given 2, I can find the rest. Problem 2 is resistors. Resistors are indicated by color codes. Goes black, brown, red, orange, yellow. Going from the resistor code, I know that the brown is 1, black is 0, green is 5. So this is a 105 resistor, meaning 10 times 10 to the 5th ohms. The second one, orange, orange, red. Orange is 3, so that's a 3, 3, 2. That's a 332 resistor, meaning 33 times 10 to the 2 ohms, 3.3K. The last one, red, yellow, yellow. Red is 2, yellow is 4, yellow is 4. So that's a 244. 24 times 10 to the 4th ohms, 240K. That's going to have resistors are indicated by colors. Problem 3 looks at Kirchoff's law. So Kirchoff's law is conservation of voltage. If I take a voltmeter, measure the voltage around a closed path, and come back to where I started, I've got to wind up at 0. So the trick here is to find one equation, one unknown. So if we go around this path, all these have to add a 0. So we get minus 100 plus 14 plus D equals 0. From that I can find D. D is 86 volts. Around this path, minus 86 plus 26 plus E equals 0. I can solve for E. E is 60 volts. Minus 60 plus 48 plus F equals 0. F is 12 volts. Around this path, minus C plus 5 plus 35 minus 48 equals 0. C is 38 volts. Around this path, minus B plus 7 plus 38 minus 26 equals 0. B is 19 volts. And finally, minus A plus 45 plus 19 minus 14 equals 0. A is 50. And it doesn't matter which path you take. If you want to get really screwy, you can sit there and say, let's take this path. When I wind up, as long as I wind up where I started, it's got to add a 0. This conservation of voltage. Conservation of current says at any given point, the current in equals current out. Here I've got 100 amps going in, 2 going out, so I don't know which is which. Let's take this one. At this point, let's get a color I can see. At this point, I've got 80 amps leaving. I have to have 80 amps coming in. So A must be 80. Now right here, I've got 100 amps going in. I have to have 100 going out. A is 80. E must be 20. At this point, 80 coming in, 65 and B must add up to 80, 15. 65 going in, I've got to have 65 going out. 60 is going right, so 5 goes down. 60 coming in, 34 going right, the remainder has to go down, 26 amps. For F, I've got 20 and 15 coming in, that's 35. I have to have 35 going out. So F's got to be 25. I've got 5 and 25, 30 going in, I have to have 30 going out. G must be 18. So that's conservation of current. Current in equals current out. It's kind of like a Sudoku puzzle. Third one is find the total resistance. In series, resistors add. In parallel, the inverses add. And I'm a big fan of HP calculators, so kind of showing how you do this with an HP. HPs use RPN notation. So if I go to Shift, Settings, Entry, RPN, I'm now using RPN notation. I can now add these using HPs. Now the RPN's a little bit weird. It takes a little bit of getting used to. There is no equals button. To add, I have to put the two numbers on the stack, like 23, enter, 56. I now have 23 and 56 on the stack. I can add them. If I multiply by 7, hit the number 7. I've got 79 and 7 on the stack. I can multiply. So HPs are all about stacks. To use it, I want to find out which one of these are in series and parallel. So these two are in series. 200, enter, 300, add. That's 500 ohms. That's in parallel with 450. In parallel, the inverses add. So take the inverse, take 450, find its inverse, add the inverses, invert again. All this together is 236 ohms. In series with 75, in series they add, this is 311 ohms. In parallel with 250, in parallel the inverses add. So take the inverse, take 250, find its inverse, add the inverses, invert back. All this together is 138 ohms. And finally, add 50. 50 plus. Total is 188 ohms. So that's using RPNs on these circuits. I highly recommend HP calculators on tests. In my opinion, they're worth 10 points. A test is a race. A calculator that will quickly get you the answer is worth points. Also, HPs get the right answer. Getting the right answer is also worth points. So I'm not really kidding when I say HPs are worth 10 points on tests. My favorite calculator is the HP42. I believe the best calculator ever built, no longer in production. You can get a free app on your cell phone called Free42. If the instructor allows cell phones on tests, that's what I would use. If the instructor does not allow cell phones on tests, the HP Prime is not bad. It's about $124 on Amazon. It's a pretty good calculator. Next problem. Find the total resistance using Circuit Lab. So what I do in Circuit Lab is build the circuit. To find the resistance, I apply a test voltage, like 10 volts, and measure the current. It says I'm drawing 52.98 milliamps from B equals IR. Let's change my color. I know B equals IR. I know the voltage, I know the current, so the resistance apparently is the voltage over current. Take 10 volts, divide by 52 milliamps, that gives you 188 ohms. So all this together, it looks like 188 ohms. The 10 volt source, it doesn't know, it doesn't care. How you generate 188 ohms, could be a single 188 ohm resistor, could be this network, could be something else. It doesn't know, it doesn't care. All it sees is when I apply 10 volts, it draws 52 milliamps. Problem 7. Find the total resistance here. Get a MATLAB, I can do that. These add in series. In MATLAB, I can do it not easily. This is actually more of a calculator type problem. Doing this, I've got 125 in series with 400. In series they add. So enter 400 plus. This is 525 ohms. In parallel with 300. In parallel I invert, take 300, take its inverse, add the inverses, invert again. All this together is 190 ohms. In series with 75, adds, this is 265 ohms. In parallel with 200, so take the inverse, 200, take its inverse, add, take the inverse. This is 114 ohms, plus 50, 164.14 ohms. So that's the total resistance. You can kind of see the HPs are actually pretty fast. We used to have races when I was in college, HPs versus TIs. HPs will dust a TI. It's much, much faster. It does have a learning curve, though. So kind of what I recommend is get used to using HPs in 111 so that when you get to circuits 1, circuits 2, you can just rattle off these problems. Again, it's worth points on tests. Finally, verify your answer in Circuit Lab. In Circuit Lab, what I can do is drag and drop, build the circuit, apply a test voltage, like 10 volts, and find out how much current I draw. According to Circuit Lab, if I apply 10 volts, I'm drawing 60.92 milliamps. From V equals IR, 10 volts divided by 60.92 milliamps is 164.14 ohms. Same thing I calculated. So that is homework set number, well, that's not the homework set. One more problem. I can do voltage division as well. With voltage division, like B3, I know it's what I'm measuring. It's 400 over the total resistance, 400 plus 125. That percentage, B2. So the trick on this one is, if I knew B2, I could find B3. If I collapse all these together for resistance, if I knew B1, I could find B2. Collapse all these together, find a resistance. If I knew B0, I could find B1. Well, I know B0. So doing the same thing we did before, these in series and parallel, series, parallel, all this looking right is 114 ohms. So B1 by voltage division is what I'm measuring, 114 ohms over the total times B0. B1 is 6.95 volts. Once I know B1, I can find B2. All this together is 190. This 190 over 190 plus 75 times 6.95 gives you 3.80 volts. Once I know B2, B3 is 400 over 400 plus 125 times B2. I get B3. 4.99. 3.80 volts. Oh, sorry about that, I read the wrong one. It's 4.99 volts for B2. It's a 4. Using Circuit Lab, I can do the same thing, build the circuit, find the voltages, and I get the same answer. So that is homework set number 7. It's not really a MATLAB assignment, it's more of a calculator assignment. If you have one equation and one unknown, just use your calculator. When I get n equations and unknowns, which is homework set number 9, that's where MATLAB really shines. But homework set number 8 for ECE 111.